beginnings before we have the talk. I'm Mike Aramon. I know many of you, but not all. We've got some new faces. I'm chairman of this group. Nice to see old faces and new ones. The Squirrel Hill Historical Society is a membership organization that welcomes non-members to our events. And we do have, and we'd like to see you consider joining us. We have forms in the back. It's a nominal $10 a year individual, $15 for couples. We're in the middle of an ongoing membership drive, and we hope some of you will take the form and either give a check today or send it in. There's an address on there. You'll also see in the back the sign-up sheet for tonight. Most of you won't have seen this. Is different than it was before. It doesn't have a date on it. We're changing our communication policy in the Historical Society a bit. Members are going to receive mailings every 2 or 3 months. We have a very active website. And anyone who wants to be on our email list, member or non, that's what the sheet is now for. We have an email list of 300 or 400, and we give meeting notices out through that. If you're a member, as I promised some people here at last meeting, we're going to do a better job of communication. The membership benefits, besides just supporting the group, are one, we'll do more direct communication. 2, we're going to reinstitute an annual reception in December. And the third is that one of our special events we do each year is a walking tour or 2. Last year we had a really good one at Chatham University. And Chatham has agreed to do this once more. I try not to do walking tours more than twice before we move on to something else, because people have then done it. So June 6th, June 5th, Saturday morning, 10 a.m. is $3 for members and $5 for non, and we'll cut it off. We're just starting sign-ups. We'll cut it off at about 25. The vice president and one of the professors at Chatham actually do the tour, which is great. So I'd urge you to consider taking a nice sunny June 5th morning, joining us. We will be at, they'll meet at the Mellon Center on the campus. Okay. I want to talk a bit now about our speakers. This sheet that's in the back, which you should take, even so that you don't have to all go to the email site to remember, is back in front for the first time. We have our speakers set up now all the way through November of next year. And so you'll see them there. Next month we will be having a woman, the executive director of Bloomfield Heritage and Preservation, come. We try to do a couple of neighborhood talks during the year, not just Squirrel Hill. And this is the next one. Janet, we have a Squirrel Hill book that we put out with Arcadia. They've done one now in Bloomfield as well, which Janet was involved in. We're going to have a Frick Park talk from the Pittsburgh Parks Conservancy in July. We take August off. And then I want you to hear closely. We're going to be moving. This church has gotten more active in the evenings, and after being our host for 8 years, could not offer regular access to this room once a month. And we're moving across the street to the Church of the Redeemer. That's still okay? Maren Cook, one of our members, has gotten that for us. It's just down a little bit on the block. We'll figure out where to do entrances. You don't have to worry about that till September, but that's where we're going to be starting in December. Our October speaker is on the history of Greenfield, and Anita Kalina Smith, who's in the back tonight, is going to come back and speak. And that brings me to my last housekeeping. I'm going to pass something we think is real interesting around. These are lists of the talks that have been given to us, for us, over the last 8 years. And this, we'll see how far around it gets, and please don't take these. But we would like anyone who's interested, because we're going to start, we've been around long enough, we're going to start doing some repeats. anyone who's interested, just put a check mark on the right-hand column of any of the subject areas that you would like to hear again. Many of you in this room will not have heard 9/10 of these speakers because we have different people come and go in this. But I'm going to start this around, and hopefully we'll get around look at it fairly quickly, and then move it on to the next speaker, but the next person. Before I introduce the speaker, any questions? Summary. Speakers list in the back. Membership list in the back. Sign-up sheet for our walking trip in the back. Please make sure and take one of all of those. Speaker tonight is Todd Wilson. Todd is a family member of the Historical Society. Todd is the son of Helen Wilson. Where's Helen? Helen, where are you? There's Helen. Helen is our new membership coordinator and one of our most active members. Todd is going to talk to us about bridges. We've had one talk about bridges by Bob Reagan, who, by the way, is coming back in 2 months to speak about the names of Pittsburgh, which is a new book he did. Remember, Bob has been here to do the steps and to do the bridges. So this is our second talk, and we'll have others on the bridges of Pittsburgh. Todd began being interested in bridges when he was a kid, and he actually wrote a book in high school called To the Point, which is in the Pittsburgh History and Landmarks Library, and it was on bridges. He's an Alderdice graduate, went to CMU in civil engineering and public policy, works as a transportation engineer for a consulting company in Pittsburgh. He's put together a website called bridgemapper.com, which you'll hear about tonight, which displays over 1,000 bridges in 15 states. He advises at CMU, part of an engineering course. He's been active in the American Society of Civil Engineers. And just to summarize a already long resume, he was named one of the 10 new faces of civil engineering by the American Society of Civil Engineering this past year. Before Todd comes up, I need help. It looks like we may need new chairs. With those in the back, as some other people come in late, sort of point out that they should just take the chairs and set them up. We're over 50 people today, which is exciting. Also, I'll point out if people come in, there are a few left over. It's great. Todd, come on up and talk to the folks.
Well, good evening, everyone. It's really exciting to be able to talk about something I love, bridges, in a neighborhood. I certainly lived in all my life and really love Squirrel Hill. So, to begin with an overview. First, we'll go into an introduction about different bridge types. We'll talk about the bridges at Squirrel Hill, and then we'll talk about bridgemapper.com and how to be able to find bridges using that site. And finally, I'll talk about the historic bridge outlook and what's going on with local historic bridges. So part one, introduction to bridge types. Now, before I go into this, I just want to give a few definitions, where an abutment is the support at the beginning or the end of the bridge integrated with the ground. The pier is the intermediate support of the bridge, so therefore the abutments are the end supports, the pier is anything in the middle. The span, when I refer to the span, is the bridge in between the supports. And if I talk about the deck of the bridge, then that refers to the roadway of the bridge. So engineering, classification of forces. The function of a bridge, well, it's simply to carry a load across a distance. Due to gravity, all loads have a weight, and bridges can be classified based on how they carry that weight. Now, you've probably heard various presentations talking about a visual approach to classifying a bridge. Well, if you see this shape, then it's this type of bridge. Well, as an engineer, I can tell you that's not the case. So, based on compression, tension, or a combination of both of them, as well as other configurations, you can accurately classify bridges. So for compression bridges, compression is a push force. it causes objects to get shorter. And materials that are really strong in compression are stone and concrete, where really concrete is just stones glued together. Now, an arch bridge is a type of compression bridge, where an arch is a circular arc that supports the load in compression, where if you think of a stone arch, each piece of each stone pushes down on the stone below it. And the road deck is either on top or below the arch. And here's an example of an arch bridge. You can see how it's just stones built up over a string. Now, a tension bridge is a bridge in which, supported by this pull force tension. Tension causes the object to get longer. Materials strong in tension include wire rope, eye bars, and rods, like steel rods. You think about a rope. If you push a rope together, there's no strength. But if you pull it apart, you get the strength. One example of a tension bridge is a suspension bridge, where it features a long cable strung over towers and anchored onto both sides. Cables are hung from those main catenary cables. And as a result, all of these cables are in tension. Here's an example of a suspension bridge. The other example is a cable-stayed bridge. Now, we currently don't have any cable-stayed bridges in Pittsburgh. The nearest one is over the Ohio River in Steubenville. Now, a cable-stayed bridge features cables that are directly connected from the road up to the tower. Again, the cables and tension are supporting the bridge. And here's an example of a cable-stayed bridge. This one's in Huntington, West Virginia. Now, tension compression, what does that mean? Well, when a beam undergoes a load, the top of the bridge is in compression, and the bottom of the bridge is in tension. Now, I know that concept is a little hard to see, so I made a little model. This is just the simple kid's toy connects. Now, I've added vertical rods, and this will just show what's going on with the forces. These rods have no structural function. Now, I'll apply a load, and as you can see, the rods on top come together, compression. The rods on the bottom are pulled apart in tension. So beam bridges exhibit both. Here's an example of a beam bridge. This is a concrete girder bridge. I'm sorry, a concrete box beam, I'm sorry. Or another example of a tension compression bridge is a truss. As to achieve greater and greater strength for a beam, it needs to be taller and taller. However, a tall beam uses a lot of material and is very difficult to erect. If you consider transportation technology in the 1800s, you couldn't bring in a several 100-foot-long girder that's 20 feet high like you can today. You couldn't put that on the back of a horse and buggy. So engineers came up with truss bridges, where you take materials, put them together like an erector set, and come up with a bridge. And these trusses are distinctive with their triangular shape. Here's an example of a late 1800s truss bridge in Washington County. Note that the top of the bridge has thick build-up members in compression, and the bottom of the bridge has these thin eye bars in tension. Now, these beam bridges have a few different configurations. If the bridge is simple, the beam or truss rests on the support at each end. If it's continuous, the beam or truss continues across at least one pier. And if it's a cantilever, two beams are projected outwards over a pier, and then there's a center span that's hung from these projected spans. The reason you do that is it gives you a longer span length. As an example, here's a simple truss, where the truss starts at the abutment and ends at the other abutment. A simple beam bridge, a concrete box beam, where again you have a beam that starts here, ends there. So you have three beams next to each other. And here's a continuous truss, where the truss continues across the center pier. and a continuous steel box girder. Now here's an example of a cantilever bridge. This bridge is in Ironton, Ohio, built in 1922. This is the oldest truss bridge over the entire Ohio River, a vehicular truss bridge, and of course it's scheduled for replacement. But you have these anchor spans that are projected out, and then this suspended span hung from the anchor spans. If you ever get a chance to look at a picture of the old Swickley Bridge, which looked very similar to this bridge, when they demolished the bridge, they took the suspended span and lowered it onto a barge. Here's another example of a cantilever. Note the shape is the inverse of the shape of the previous bridge. Again, you have the anchor spans and suspended spans. This is the Rankin Bridge, which I'm sure you've been backed up in traffic trying to cross the bridge recently. But if you ever get a chance to look, you'll actually see pins in these locations where the suspended span is attached to the anchor span. And here's an example of a beam bridge, a steel I-beam bridge, where you have anchor spans, and then you can see these pins and the hinges for the suspended spans. Now let's talk about bending. Now, with a simple bridge, when you apply a load, the span would tend to sag in the middle. The span would sag in the middle. So to counteract that force, the support structure is an opposite force. So the support structure would curve up in the middle. It needs to be thicker in the middle. Now, any comparable bridge you see that has a flat top, well, it's inefficient materials where you don't need it to be nearly as thick on the ends. Now, this bridge has a main span of over 400 feet, which is why it needed to be thicker at the top. Now, just go back for one moment, please. One thing I want to note about this bridge, it is not an arch bridge. Even though it has a circular top, it's not because of compression, it's because it's curved upwards to counteract the larger force pushing down in the middle. For a continuous bridge, there will be bending over an intermediate support. If you're loading the bridge here and you're loading the bridge here, you'll have a bending action over that support. So, therefore, they may be thicker over that pier. And with a cantilever bridge, it's the same thing, where again, you have bending over these supports for the suspended span. That's why they need to get taller at the tower. Now, if any of you have ever seen our materials for Beaver County, they feature, in their logo, they show a suspension bridge. But the bridge they're actually talking about is a cantilever bridge. Cantilever bridges have towers, suspension bridges have towers. But you can see it's because of the bending that the cantilever bridge needs to have a tower. Now, classifying bridges by form, they're classified based on where the road is in relation to the support structure. So a deck bridge has a structure beneath the road. A pony bridge has a structure next to the road, not above the road, just next to the bridge, because it's just not grown up enough to be a full-size bridge. And a through truss has the support all around the road, and the half-through has the road in the middle.
Can I ask a question?
Yes.
When do you choose what type of bridge you're going to put over that water or railroad things or whatever you're using the bridge for?
Well, a lot of times it's based on the site conditions, where if you need vertical clearance underneath the bridge for, say, a railroad or for navigational clearance for a river, you tend to go with a bridge like a through or a pony where the support structure is above the road. If the bridge is higher, like over a valley, it makes more sense to put the support structure below. Now, the difference between pony and through is that ponies are typically smaller bridges and throughs are typically larger bridges. And with a half-through, this type is built so rarely that it's a very special case where you'd see them. In all of western Pennsylvania, there are only 2 examples. And it's a situation where it helps to have some of the bridge below the road, but maybe you can't fit all of the bridge below the road because of clearances.
What about the covered bridge that
Co-
used to be, and you don't see anymore?
Covered bridges are through truss bridges that just have a covering to protect the wood. So they're typically covered bridges are simple through trusses.
Why was it built,
Why was?
the covered bridge built?
Because early materials, you have a lot of trees growing near the bridge, and rather than when you're talking about the 1800s, where you don't have a lot of materials either at the site or easily accessible to the site, you cut down trees and build a bridge. You cover it up so the wood doesn't rot. Just like with stone bridges, you could quarry the stone near the bridge, but with steel bridges and concrete bridges, and you needed more equipment, factories to get that material and bring it to the site. Now here's an example of a deck bridge. You can see the trusses are below the road. This bridge used to be over the Youghiogheny Reservoir. There's a pony bridge, where again you can see the trusses alongside, but not over the top of the road. And a through truss, where you're driving right through the middle of the bridge. And here's an example of a half-through, where this bridge was built as a railroad bridge and converted to vehicular use, where the deck is right in the middle of the bridge. Now let's get into the historic bridges of our area. Now, there are a few bridges that are actually inside Squirrel Hill. Well, why is that? Because it's a hill. Squirrel Hill. The bridges are at the boundaries of Squirrel Hill, where there are rivers, streams, and ravines. So that's why the bridges cross into Greenfield, cross into Oakland, cross into Homestead. Now, there were few roads in the area until the late 1800s. And this area really became developed in the late 1800s and mainly the early 1900s. And now these early first-generation bridges, as we discussed, were made from wood or stone. And in Pittsburgh, earlier bridges were built from iron because we did have industry here. And now, just about all of these, say, first-generation bridges were replaced in the early to mid-1900s, a lot of times with the bridges that we still have. Now, supposedly, the oldest bridge in this area is the Duck Hollow Bridge of 1886. Now, this bridge spans the mouth of 4 Mile Run. You see, this is the Homestead High Level Bridge. That's the waterfront.
9 or 4? 9.
Yeah, 9 Mile Run. I apologize if I said 4 Mile. Now, the bridge carries McFerrin Street, which used to be 2nd Avenue. 2nd Avenue used to run all along the river through 9 Mile Run. There were even connections through what is now Frick Park up to Regent Square. And the bridge was constructed in 1886 and rehabilitated in 1936. Now, I can't find any account to really determine how much of the bridge was rehabilitated or reconstructed. I'm not convinced that the support structure of the bridge is from 1886, but I can't prove or disprove that. Now, this bridge is actually eligible for the National Register of Historic Places because it was one of, if not the first bridge, to use an open grate deck. Now, in Bob Reagan's Bridges of Pittsburgh bridge book, he does state this is the first bridge ever built with an open grate deck. Now, the original wooden deck was washed away in the Great Flood of 1936, and it was replaced by a grate deck. Now, the bridge is also located in a very important historical site, the mouth of 9 Mile Run at the Monongahela River, which is known as Brown's Landing, near the Highland Station of the B&O Railroad. And salt works operated in that area in the mid-1800s. Here's an image of the old Browns Bridge, which was Squirrel Hill's river crossing to Homestead. The bridge was built in 1897. Now, back at that time, just about all of these bridges were built privately. They were built to make money because people needed to cross the river, build a bridge and you charge a toll. Streetcar companies also wanted to expand their lines, and they needed bridges. So these bridges were built, toll bridges and for streetcar bridges. And the Pittsburgh approach and abutments still exist for the bridge.
Where is it?
On the next slide, you can see here's the abutment for the bridge. Here's the Duck Hollow Bridge. This is the wharf. And that's through aerial photographs. And this is the old approach leading up to the bridge. You can see the old wall. And this is on Old Browns Hill Road. If you use Google Maps, you can see the line for where that road used to be. These are property lines that are in gray.
You're saying that's the approach to the old bridge?
Yes, the old bridge the old road came up here, and right here is this abutment, crossed the railroad tracks and went across the river to Homestead.
And it went across. Can you get to that? I mean, can you easily see it, or is it covered with?
Well,
Yeah,
it's very difficult to see it from the Squirrel Hill, Hazelwood side, because these active railroad tracks, and then there's a drop, so these trees tend to obscure the view. Now, if you're interested in seeing it, you could, I guess, park on Old Browns Hill Road or walk up Old Browns Hill Road and walk along the old alignment. And you can also see the stones from the other side of the river. So if you're dining at Uno's or Eden Park, you can look across and notice that abutment. That's actually the first time I noticed the abutment was when I was doing Now, that bridge was replaced in 1936 by the Homestead High Level Bridge that we all know and love. The bridge was built from 35 to 37. Now, the bridge was designed in-house by Allegheny County. At one point, Allegheny County had about 100 engineers working for them. It was part of County Commissioner Joseph Armstrong's ultimate highway system of 1924, where he reorganized the county's Department of Public Works and decided that the engineers were going to work for him and completely eliminate the need for engineering consultants. Now, I work for an engineering consultant, so, now, while the county got really, the County Department of Public Works got really big at that time, there was also a lot of patronage and scandal. As a result, the Democrats were able to unseat the Republicans at the time, which is still has held true ever since in this area. And they were going to shut down the large Department of Public Works. But then with with the Great Depression, the federal government for the first time started paying for infrastructure improvements. And as a result, since Allegheny County taxpayers no longer needed to pay for all this work the county was doing, the Department of Public Works stayed large and still built very innovative bridges through the Second World War. The bridge is also noteworthy for being over 3,000 feet, one of the 10 longest bridges in the country at the time, and has two main spans of over 500 feet. Now, what's really significant about the bridge, if this isn't significant enough, is this Wickert truss. And I pronounce it Wickert because anyone I know who worked for Allegheny County pronounces it Wickert. Now, this was the first ever example of a Wickert truss. Now, the Homestead High Level Bridge is a continuous truss, whereas you see the trusses continue along over piers. Now, the problem with a continuous truss before computers is if there's a truck before a pier, what's going on with the bridge after the pier or after the next one? It was a very difficult problem, and as a result, engineers never really built continuous truss bridges. So what Wickert developed was a diamond shape that is hinged. There's two hinges here, it's hinged here, two hinges here, and here. And what all those hinges allow is for each of these members to move. Now, I'm sure you've sat on the bridge and you feel it. This is why, because of all these hinges. Now, as a result, if there's a truck that's loading this span isn't affected. Each span on a continuous truss is statically determined. So that's the advantage of this type, and about 5 other bridges like this were built.
Why don't they build more for that? That's such a good idea.
Well, it really is an inefficient design. It was really just for the ease of engineers. And once you had the advances in computer technology, you were able to start building continuous trusses. So now you'll see a lot of continuous trusses that have no hinges throughout the entire bridge. So I think the Norham and Nesson bridges, or the Freeport Bridge, are probably examples of that.
Are they built for structure or aesthetics?
Predominantly bridges are built for structure. The only time bridges were built for aesthetics were from the city of Pittsburgh and Allegheny County between, say, 1910 and 1940. And at that time, at least the city had a very influential art commission that mandated the design of bridges. The 6th, 7th, and 9th Street bridges were supposed to be truss bridges, but the art commission said no. Yeah, throw those designs out. We want suspension bridges. So that's why they look the way they did. Now let's talk about the Old Murray Avenue Bridge. This sculpture here is from the Old Murray Avenue Bridge. Now the structure was completed in 1914 and lasted until 1977. Now starting in about 1910, going through the mid-1920s, the city of Pittsburgh built 8 City Beautiful style open spandrel concrete arch bridges. Only half of them still survive. These sculptures were moved to the intersection of Washington Boulevard and Allegheny River Boulevard. And on the next slide, we'll see there's an image of the bridge, and you can see the sculptures right here, right there. Now this picture was taken in 1958, and you can see the deterioration that already began with the deck of the bridge. Now, in 1977, the existing bridge was built. As you can see, the bridge has absolutely no aesthetic features.
Just functional.
It's functional.
No aesthetic.
We probably use it every day. So. Now, another one of these City Beautiful concrete arch bridges is the second Beechwood Boulevard Bridge. And I say Beechwood Boulevard Bridge rather than Greenfield Bridge because it's inscribed in the plaques, Beechwood Boulevard Bridge. Well, since then, the city has erected a sign that says Greenfield Bridge. So call it what you will. Now, the bridge was completed in 1923, and the contractor was Wickert, the same guy who invented the Wickert Truss. Now, the bridge was built to be very beautiful, to be an entrance to Shenley Park. They had ornamental panel parapets, cast bronze light fixtures, sculptured urns, and these monumental pylons, which still exist. Now, in 1980, the bridge was rehabilitated, everything but the arch was stripped, and a new deck that's made of steel that didn't match the original bridge was installed. The arch was patched, and unfortunately, the concrete they used to patch the arch didn't bond properly. That's why all that new concrete is falling off the bridge. Now, keep in mind that arch is about 20 feet tall. So says my friend who was working on the project. So the bridge can still lose a lot of concrete and still be strong. And here are pictures of what this bridge used to look like. You can see how the urns and lampposts went across the entire deck of the bridge. Now, compare this with the view today.
Oh, wonderful.
Another notable bridge is the Parkway East Commercial Street Bridge, which was completed in 1950 and built by the state. After the Second World War, the state got a lot more involved with building new infrastructure and major roads. And the bridge is one of only 2 concrete arch bridges built for the Parkway. Another one of the Parkway East bridges is the Fraser Street Bridge, which is an example of a deck truss. and it was also completed in 1951. Now between that bridge and the bridge over Saline Street in the 4-mile run section, they're the busiest bridges in our neighborhood, with carrying 120,000 cars a day. Now this bridge is actually, and if you go back one slide please, the bridge is actually composed of 2 parallel bridges. You look, there's a line here where the bridge on this side is separate from the bridge on the other side. And it's the longest parkway bridge over the valley, and the bridge, as well as all of the parkway's original structures, are eligible for the National Register. Now the Swinburne Bridge, which is perpendicular to the Fraser Street Bridge, you can see that here, carries actually Fraser Street, where Fraser Street is perpendicular to Swinburne Street, and the rest of part of Swinburne Street was demolished when they built the Parkway East. So that's why if you're on 2nd Avenue, you'll see Swinburne Street reappear. Now it replaces a previous trestle, and this bridge is built as a combination of girders above and below the road. Now, most of the old city bridges were trestles. This is the last one that's left. Now, in Shenley Park, the original Boulevard of the Allies Bridge, where is this Wilmot Street Bridge, or Wilmo Street Bridge, and it was built in 1907, and an example of a large arch bridge, one of the few metal arches rather than concrete arches. The reason this bridge was a metal arch is it was so much bigger than the other arches built at that time, and it lasted until 1939. Replaced by the current Charles Anderson Memorial Bridge. Now note with this bridge, you have the open diamonds like the Homestead High Level, because this is our region's other wicker truss. Now, and by the way, the stone piers for the Wilmot Street Bridge still remain, so if you're walking on the trails in Shenley Park, you can see those stone piers. The bridge is noted for its Art Deco style pylons and railings. And Charles Anderson was a plumbers union labor leader, a supervisor for the Department of Labor during the First World War, and then at the Pittsburgh City Council. And here's what the bridge looks like today. The railings, original railings, are still here, as well as the Art Deco pylons. Now let's talk about the bridges of Shenley Park, including some bridges that are actually in Squirrel Hill. Now the land was known as Mount Airy, and it was owned by the Captain Edward Shenley family. Now in the 1860s, Councilman William Phipps proposed that the land, which was still undeveloped, or maybe there was some light farming, but it wasn't developed as some of the other area around it, proposed that it would be converted to a park. There was a referendum, and the residents said, well, we don't need a park. We could just go out a little bit. There's plenty of woodlands. Why do we need land to become a park? Well, in the late 1880s, development was encroaching and the land was actually considered for housing. So Edward Bigelow, who was the director of Pittsburgh's Department of Public Works, raced to London, literally raced to London, to be there first to convince Mary Shenley to donate or sell the land as a park, which some of the land was donated, some of it was sold. Now the original bridges in the park were rustic bridges. They were constructed of wood. Now, one of the first bridges built into the park, notice it was built in 1890, where the park was established and was purchased in 1889, was this trestle, which you can see it's definitely not suitable for modern traffic. And when the casino in Shenley Park, which was had one of the first indoor ice skating rinks, when the casino burned in 1896, it damaged this bridge, so they replaced it. By the way, this lower bridge was built as a streetcar bridge for a line that was supposed to go through the park, and Bigelow was successful in getting the line to be shut down and removed. Now, with the fire damaging that bridge, instead of just replacing that bridge, they decided, let's just build 3 bridges. So the first is the famous Belfield Bridge, which was between the library and Forbes Field. Now, in the 1910s, this ravine was filled in by land excavated from Grants Hill downtown. So the bridge was buried. And now is the sculpture Song to Nature, which is located approximately above where the bridge still stands. Now the next bridge, which also still stands and is a little easier to see, is the 1897 Shenley Bridge. Now this bridge replaced the trestle. Now what's really noteworthy about this bridge is it's a 3-hinged arch, and I'll explain that when I discuss the similar Panther Hollow Bridge. The bridge is listed on the National Register of Historic Places. Now, here's a picture of the Panther Hollow Bridge, which is the twin of the Shenley Bridge. And when I meant 3-hinged arch, the arch has hinges at the abutments, but it also has a central hinge. So if you look up, there's actually a hinge with a pin in the center. And that allowed the arch to flex. Now, the 3-hinged arch was a lot more difficult to design and build, which is why you don't see them very often. But just as a side note, the main span of the 31st Street Bridge and the Washington Crossing Bridge are both 3-hinged arches. Now, the Washington Crossing Bridge was an architect-designed bridge. They thought the hinges looked ugly, so they put shields in front of them.
What qualifies a bridge to be historic?
There's a variety of categories where not every old bridge is a historic. Typically, reviewers look for a bridge that was either technologically significant, meaning that this bridge had some sort of decal or some sort of feature that pioneered or advanced bridge design, or had a feature that was, say that they tried something different which didn't succeed. So some noteworthy feature.
Todd,
Yes.
the terms for the National Register would also allow it to celebrate a particular engineer or architect.
Absolutely.
If they're famous, you could get on the register.
Absolutely. For an example, any of, say, Roebling's or Lindenthal's bridges, who built bridges in Pittsburgh, would almost definitely be eligible for the National Register. And with historically significant, not just the engineers, but also if, say, there was an important historical event that happened in the bridge, or if the bridge is and determined to be contributing to a historic district. Now, the Panther Hollow Bridge is a little bit more famous than the Shenley Bridge due to the panther sculptures. And the bridge is also a little bit different because there are 4 lines of arches below the deck. The Shenley Bridge actually has 6 lines of arches. Now, in Shenley Park, there are also these beautiful tufa bridges, which are standard concrete arch bridges, but to be decorative are encased with this this tufa, this porous crystalline material that came from Ohio. These bridges were installed in 1908 when the bridle path was created for the park. Now, if you've noticed the little stone bridges in Shenley Park, these bridges are actually a lot newer than those tufa bridges. These bridges were built by federal New Deal funding in the 1930s by the Works Progress Administration. 15 of these bridges still survive, more or less. A lot of them are in pretty bad shape, including some where you walk across the bridge, and after the bridge is the stream, because the stream's covered you path. So, go to the next slide, please. So, here are 4 of the WPA bridges. Now, while they look like they're old stone arches, as you can see by this deteriorated bridge, they're actually concrete arch rings faced with stone, and then filled up with fill for the path. Now, part 3. We'll talk a little bit about the about bridgemapper.com. Now, created by myself and Lauren Winkler, if you'll please stand. So, together, we developed the site Bridge Mapper, and currently we have over 1,000 bridges in 15 different states. Now, if you think that's a lot, there's still well over 1,000 bridges in 15 other states on my computer that haven't been uploaded to the site. Now, it's currently the largest single photographer bridge website. While there are bridge websites with many more bridges, they all have other contributors. And this site has the most complete coverage for southwestern Pennsylvania. So this is what the site looks like. Now, there are 3 different ways of finding bridges with the site. The first way, say you click on Bridge Map. So you click on Pennsylvania. So you click on Allegheny County. Here's a map of bridges of Allegheny County. Now, I apologize, currently there are only 231 bridges in the county. I've seen about another 100, and I still have other bridges that I still have to photograph in the county. Now, there are 2 different ways of finding bridges with this interface. And again, and Lauren is the one who actually is the webmaster and designs this very innovative interface. You can this is a fully functional Google map, where you can zoom in and click on a bridge based on its location on the map. The other option is to click on it on the list. So let's say we click on the Glenwood Bridge. This is what a typical data page looks like, where here's the bridge on the map, here's an image of the bridge with information. Now, there are other options, other features too. You can click on Street View, and you can virtually drive across the bridge, anywhere that Google Street View is available. You can click on Virtual Earth, where you get an aerial image of the bridge. Now, you can't see anything, you can't see what the trusses look like looking to the north, so let's rotate this image. There, that's better. Now, when I talk about trying to make, with this site, trying to make it easy to find bridges, you can actually click Directions. Type in your address to the bridge and click Go, and that shows you how to get there. Now, the next way of looking for bridges is with the All Bridges tab, or link, and that shows you a Google map showing every bridge currently on the site. You can either use the search feature to find a bridge, or you can zoom into the location on the map. Say we zoom into Allegheny County, and again we can click on the Glenwood Bridge, click on the Glenwood Bridge, and there's a data page for it. And there's a Street View image that's below the Google map, which I couldn't fit on the screen. Now, the third way of finding bridges is through this bridge list, where all the bridges on the site are listed in alphabetical order. So go to the page that has the, just keep going to the next page until you find the specific bridge you're looking for. Like say we go to page 13, here's the Glenwood Bridge, a little bit over a covered bridge, and over the Golden Gate Bridge. You click on the Glenwood Bridge, and then it's a similar, the similar data page. Now note that these data pages are useful if you want to link this to another site. The map channels, the map-based pages do not have individual addresses. All right. Lastly, we'll talk about what's going on with historic bridges in our area. All right. Well, currently, any of these historic trust bridges that haven't been rehabilitated or restored will be gone within just 15 years. While the federal government offers either transportation enhancement grants, which can pay up to 80% of the cost for a rehabilitation project, or Section 106 funding, in which the demolition money could be used to rehabilitate the existing bridge. The federal government also pays 80, in some cases 90% of the cost for a new bridge. Now, our agencies are trying to do as much as they can with as little funding as they have. They simply just can't afford to spend more money to maintain historic bridges when they can spend just a little bit more and get a brand new bridge. So therefore, almost all of these historic bridges in the state are to be demolished, probably 95, 99%. of these historic bridges. The only exceptions are famous urban bridges, like in the city of Pittsburgh, 31st Street, Panther Hollow, Shenley, Smithfield Street, and bridges that are supported by the community. One example is the Denora-Webster Bridge, which is just south of Pittsburgh in Washington and Westmoreland County. This bridge is from 1906. If you notice, it looks a little bit like the old Browns Bridge. Well, and when we think of Denora, we think of the Denora smog disaster. Well, this bridge was there. This bridge was involved in the story of that disaster. It's been listed on the National Register of Historic Places for over 20 years, but it failed an inspection, was closed to traffic, and now State Senator Barry Stout is pushing for its replacement instead of repair.
Todd?
Yes.
A question. Am I right that covered bridges have gotten some of their own protection, they become sexy?
Yes, absolutely. That's an excellent point. Thank you for bringing that up. Covered bridges have their own special protections, and now you pretty much can't demolish a covered bridge. There's always funding to completely rehabilitate a covered bridge. And when that happens, what they do is they install new beams underneath the bridge. So really all of these covered bridges are now just beam bridges with the decorative wood on top. Some of the covered bridges that I've seen, the majority of the load-bearing, or what used to be the load-bearing material, has actually been replaced. Metal truss bridges, on the other hand, while I've seen a few that have been retrofitted with beams, chances are they're just going to be torn down.
Is it cheaper to build new than to rehabilitate?
It is not cheaper to build new, but the costs may be, say for an example, with one of the bridges in central Pennsylvania, to do a full rehabilitation, bringing this bridge from the 1800s up to loading that it can carry school buses, that will cost $1 million. To tear down the bridge and build a new one will cost $1.2 million. So it costs less to repair, typically less to repair, but not that much less. And however, there's a comparable bridge in Michigan where they were able to do the same thing using a different type of technology, and it was only $500,000. But that's not really done around here. Another example is the Turnpike Bridge over the Allegheny River, which is already closed to traffic and will be demolished shortly. The Halton Bridge is another example.
Didn't they just work on the Halton Bridge a few years ago? I thought it was...
Yes, they did. They renovated the bridge. The bridge does not even have a weight restriction, but the bridge is very narrow and is quite a bottleneck for the area because there's no other way for that part of the river to get to Route 28. Yes, they're going to build a new, new beam bridge. It'll just be a simple beam. But it will be 4 lanes. And the new bridge will be open to traffic, and then the existing one will be torn down. And that's the other advantage with building a new bridge is you can maintain traffic. You don't have to restrict it or close it, like with the homestead high level arrangement. The historic bridges in Allegheny Commons, Ridge Avenue, Ohio Street, and the pedestrian arch are all slated to be torn down. The Charlotte Reminiscent, and the other of the big multi-span early 1900s Monongahela River bridges, that one will be torn down in a few months, leaving the Monongahela River with just 2 old truss bridges, the Smithfield Street Bridge, and when I say old, I mean pre-World War I truss bridges, the Smithfield Street Bridge and the old Brownsville Bridge, which is a single-span bridge. Another example is the Dorrington Road Bridge. Until last year, it was Allegheny County's oldest unaltered truss bridge. You can see these are the original builder's plates by the Pittsburgh Bridge Company from 1888. The bridge had a 9-ton limit, served a 1-lane switchback, and was demolished and replaced with a 2-lane bridge starting last summer. St. Vincent High Bridge, which is a rare example of a pin-connected truss with X's. And that bridge is now gone, and I've never seen another one like it. And the Davis Avenue Bridge was the last of the city's pre-1900 bridges over valleys. And that bridge, they rehabilitated it in the 1980s. the contractor didn't do a very good job, and it ended up causing more deterioration. The city closed it until the bridge deteriorated to the point it had to be torn down. But in other parts of the country, I should say in Pittsburgh and in other parts of the country, the future can be bright for historic bridges. Here's a bridge converted to carry pedestrians in Grand Rapids, Michigan. They were having an art competition, Art Fest on the bridge. You can see that table is the size of the bridge. There were other art displays on the bridge. There's the Shelby Street Bridge in Nashville, where they added these river viewing platforms, decorative lighting, and other improvements. This is Calhoun County, Michigan, where when they, once these historic bridges can no longer support traffic, some of them are moved to this bridge park, and they have trails going across the various bridges. And those are the bridges decorated for Christmas. And this is in Shelburne Falls, Massachusetts. It's called the Bridge of Flowers, where they now garden this former railroad bridge. You can see all of those vegetation. So there are other ways that you can reuse bridges when they're no longer functional for vehicles. Unfortunately, other than in Pittsburgh and the rail trails, you don't see that around here. Any questions?
Will the bridges that we're building today last longer than the ones that went up in the 30s?
Well, that's certainly for debate. And I think we've seen that a lot of the bridges built in the 1950s and 60s are the ones that have a lot of problems, like the ones that are collapsing, like the one in Minnesota, the Lakeview Drive over in Interstate 70. There's a lot of those bridges with the first generation computer technologies where engineers were more sure that the computers knew what they were doing without the factor of safety. A lot of those bridges have been having problems. As for the new bridges, it's certainly hard to it's certainly hard to say. The engineers say they will, so I'm sure at least some of them will. I should also point out that while we do have some old bridges that has survived, a lot of the old bridges lasted 20 years, and that was it. So.
Because of natural disasters that we've all heard about, where the bridges split and all of a sudden cars fell in and people were killed, and they showed it on television, and they were horrible disasters. Why did that happen? Why wasn't it noticed that there was problems and that this bridge is going to fall apart under the weight?
Well, I guess in that case, each situation would be different, but especially with older bridges, they weren't really designed to accommodate any type of weather conditions or other types of disasters. Like there were some bridges that were only, like the Tay Bridge, which collapsed as a train was crossing it in the late 1800s, where the bridge was only designed to support downward weight. Well, there was a storm in the weight, and the winds pushed up on the bridge, thus collapsing it. The Tacoma Narrows Bridge, Galloping Gertie, is another example, where that was the bridge that the deck was oscillating and eventually collapsed. That bridge was long and narrow and designed with a wall of stiffening girders. So as the wind hit the girders on the side of the deck, caused the deck to move, so the wind could get by the bridge. The engineers never thought about the winds coming from the side like that, and as a result, that bridge collapsed.
Because they said that was going to happen with the Rankin Bridge, we were advising people to go over before they restructured some of the underpinnings.
Well, generally, in 99.9% of the time, if the bridge is open to traffic, it is safe. And in the case of the Rankin Bridge, the media did, after the bridge collapsed in Minnesota, the media looked at inventory reports, said, well, any type of bridge that has the same general configuration is at risk. And it was sensationalized, and very few bridges were that similar, and the Rankin Bridge was not that similar. The media might have said otherwise.
I remember as a kid having a bubblegum wrapper that was saying that this bridge in Brownsville was the very first one of its kind. What is it and what made it unique?
Well, the Dunlap's Creek Bridge in Brownsville, which is on bridgemapper.com.
I go with the Monongahela.
This is over Dunlap's Creek. It's not Monongahela. It's over just a small creek. That bridge is the oldest, and it was the first ever all-iron bridge built in the entire country.
And that was it?
That's it. It's still there. It's still carrying traffic. It does not have a weight limit.
What's the name of the road that goes across?
That's the main road in Brownsville.
That's Route 40.
The old Route 40.
Yeah, it's
Oh, Route 40.
And just click on Fayette County on bridgemapper.com and you'll be able to.
And it's Washington County on the other side.
Correct, that's correct.
Todd, do you have a favorite bridge?
You know, I'm asked this a lot, and it's really, really hard for me to choose favorites because there are just so many bridges are so unique for various reasons. So I think in general, the big old through trusses like say the Denora Webster, Charlotte Reminiscent, Smithfield Street are my favorite type, but it's certainly hard to have that number one.
Before people start leaving, I learned something tonight. This is our biggest crowd we've ever had with slideshow. We've had a couple of others that weren't so dependent on slides. The Historical Society is going to spend some money and buy a screen that goes up to the ceiling so everyone can see better. So apologies for those in the back. Any other questions?
Do you know much about the Riverton Bridge in McKeesport? Like who designed, who was the architect, who?
Yeah, I was actually talking about that bridge at a presentation last night. Maybe I should go and pull up that presentation.
Yeah, I'd like, I walk across, I'm from White Oak, so I'm on that bridge all the time.
The bridge was built in 1891 by the Pencloyd Iron Works. And that company almost exclusively built railroad bridges. Their most famous bridge was a steel arch bridge over the Niagara River. And in 1902, that company was absorbed by American Bridge.
And where were they located?
You
know, okay. And how do you spell it? It's P-E-N-N?
P-E-N-C-O-Y-D.
C-O-Y-D. Because I can see there's a plaque, there's a metal P-E-N-C-O-Y-D.
Yes. Yes, and again, that bridge is on bridgemapper.com as well as pghbridges.com, and I neglected to mention pghbridges.com, which is an excellent source for Allegheny County bridges, and unlike me and Lauren, really focuses on Allegheny County.
You said you're going to end up with about 400 bridges on your site in Allegheny County.
Correct.
There are 1,300.
There are, actually, according to Pittsburgh History and Landmarks book, there are 1,674 bridges in the county. Right. Right. More bridges in the county and 444 bridges in Pittsburgh, according to Bob Reagan, which he says is the most of any city in the entire world. But only a small percentage of the bridges are either historic or otherwise old and interesting.
So the county leads the number of bridges, the number of municipalities, right?
Right. Just to consider, I currently have 15 states on the site for about 1,000 bridges, where 231 of those are just our county. So,
In the back, do you have a number?
How about the bridge at Forbes going over Quick Park to Braddock? I think a lot of people think that's the Squirrel Hill Bridge. Do you know anything about it?
Yeah, the bridge was originally a steel arched bridge. It was built in the late 1800s, as was Forbes Avenue's bridge over Junction Hollow. Now, the bridge over Fern Hollow was also a three-hinged arch, like the, I guess more like the 31st Street Bridge, or the...
I thought the bridge that's there now was built around 1922.
The current bridge was built in the 1970s.
Okay. So you say there was other bridges before that?
Right, right. In almost all cases around here, there was a bridge before. I don't know if there was a former Murray Avenue Bridge, but there was a former Beechwood Boulevard Bridge.
I wanted to know, when you go on Washington Boulevard, there's a bridge overhead. Where does that go? I've always wondered, what is the name of it?
Right. Well, there's the Stone Bridge, the Stone Arch Bridge, and there's also the
Right, it's all
concrete
arches,
arch.
yeah.
Right, and they connect the neighborhoods and
Lumber Avenue.
There's Lincoln Avenue is one, Larimer Avenue is the other. Right. The only time I've ever driven across the bridges was with my driving instructor back in high school. But the bridges are still functional, and the Larimer Avenue Bridge, which was one of the main city beautiful bridges in the city, that was actually the second longest concrete arch bridge in the world when it was built. And those were all surpassed by the Westinghouse Bridge.
When you were talking about the Halton Bridge going 4 lanes, I used to live out there in that area, Pin Hills, and I always thought between Halton and Holland Park Bridge, I always thought there should be a bridge in the middle.
Right.
You know what I'm talking about, between the 2 bridges?
Absolutely.
There's a big gap. Is that considered state or county? Because it seemed like it would make sense for the state, bridge between the 2 bridges.
Right.
You know what I'm saying? There's a big gap.
Absolutely, and it's very difficult to get a bridge at a new location built these days because a lot of times communities don't want the traffic or don't want the
No, I always thought that, a while back.
Now, back in the 1970s, associated with the construction of Route 28, there was talks about building a new bridge to replace the Halton Bridge, to actually do a direct connection from 28 to Allegheny Boulevard. But there was a lot of budgetary problems in the mid-1970s, and that.
Yeah, that was one of why there's a big gap in bridges.
Back first.
Do we know of any bridges made of core 10 steel? Like the Rusty building downtown is supposed to be this special stuff that is made for bridges. Do we know of any around here?
There are bridges, the Fern Hollow Bridge in Forbes Avenue in Frick Park, it's made from core 10 steel. That bridge actually won our most beautiful bridge prize by the American Institute of Steel Construction when it was built. And but there are other bridges in the area, and the new Ford City Bridge is another example over the Allegheny River. And a lot of times now in, say, more scenic areas, they like to claim that the core 10 steel, since it rusts, it's more natural looking and it's an aesthetic treatment.
Of course, I was told it never needs maintenance, so that sounds pretty attractive.
It depends on the quality of the steel, because if any of you are familiar with the Allegheny Highlands Trail on Laurel Ridge over the Pennsylvania Turnpike, there was a little A-frame core 10 steel pedestrian bridge. They just tore it down because that bridge was going to fall down anyway. That bridge started to rust, never stopped. Like in the state of Michigan, they no longer build core 10 steel bridges because they've had a lot of rust problems with them, and they've painted all of their core 10 steel bridges. But yes, they are still alive and well and being built in this area.
Well, mine, some of the Greenfield Bridge, you mentioned having the concrete come off because the company that rebuilt it did a bad job. What's done to make sure that that doesn't happen? That good work is done everywhere.
Well, a lot of times the work is only guaranteed for a very small amount of time. Like one of the issues going on now at the sidewalks in Point State Park, where the sidewalks are just over a year old and they're already deteriorated, and well, those were only bonded for 1 year. So
doesn't it get inspected to make sure it's being done right in the first place?
there are always, there are inspectors on the job, and sometimes, but there are various problems that pop up, not immediately. And there's also, it could be design issues too, where maybe with the Beechwood Boulevard or Greenfield Bridge, the engineers thought that this one design for a bonding agent would work, and it ended up not working. So when something goes wrong with the project, there's plenty of blame that's passed around to everybody. But also keep in mind that all of our projects were all done with low bid construction, so that makes you feel safe, right?
So you see now, I think there's one that I was viewing, these mainly interstate highway bridges with the construction, I guess it's suspension right in the middle of the auto lanes. They're attractive. There's nothing on the side and it just goes up. Is that a suspension type bridge?
In Wheeling?
Well, I'm talking, I think there's one in Wheeling on.
It's Steubenville.
Steubenville.
Right. That's the example of the cable stayed bridge.
A
cable stayed bridge. And yeah, that's the only example around here. And that example, that type of bridge was actually originally derived from sailing ships of ancient Egypt.
They were gonna build one in Pittsburgh, right? There was plans to build one from the tunnel,
Right,
Wabash Tunnel to
right, there were plans for the Wabash Tunnel. They ended up choosing an arch, a bowstring arch design, but then that project is not going to happen. Now, if they ever build the Monfayette over the Monongahela River by Kennywood,
Yes.
that design is currently supposed to be a cable stayed bridge. Now, will it ever be built?
You know anything about that stuff?
The latest on the Monfayette is the turnpike doesn't have the financial resources to build it. So
How many years have we talking about that?
right,
I mean, they go up to here somewhere, we're supposed to end around here somewhere?
right. It was supposed to end with tying in with the parkway east of Bates Street. And the turnpike advertised the project to private companies to do a private-public partnership. If you build it, we'll give you the design. Well, again, with this economy, no company really wanted to spend the billions of dollars that it would cost.
Do you think that would help the area develop with it develop?
Yeah, parts of it, I would say absolutely. Other parts, it would really depend because there are certainly a lot of pros and cons.
Yeah, I heard both ways, that's what I was wondering.
Yes. So it really affects people differently. Does it help to have a bypass for downtown?
Yeah.
Absolutely. We don't have any major arterial
That's why I thought
roads.
it would help, because it's,
You know,
you can go here and here without going downtown, you know.
absolutely. You know, you live in the east and
Right.
you work by the airport. You have to go through downtown, and
Right.
you're adding to the congestion of Squirrel Hill and Fort Pitt. You divert the traffic away from the city. Absolutely, that will help.
I thought it was cool.
But there's
You can make progress, you know,
right. But there are certainly a lot of disadvantages as well as advantages. So it's
A couple of other questions, if we have any.
What's the worst designed bridge now in Pittsburgh?
the worst
What about
design.
Fort Pitt?
Holland Park?
Fort Pitt is pretty.
Where's the worst?
Well,
Okay.
again, that's a good question. I mean, I will say that the highest collision rate in the entire area is on the Fort Pitt Bridge.
Okay.
But a lot of people like to say the Veterans Memorial Bridge is the worst designed bridge because it's the only bridge that has no aesthetic properties downtown. But as to any bridge that's around here that's purely bad design, that's certainly hard. And yeah, I don't know of any bridge that was just completely a bad design here.
Probably the fracture critical bridges, bad design turned out.
Well, while in some ways, yes, a fracture critical bridge is the type where if one major structural member fails, the bridge would be at risk for total collapse. For example, with these old truss bridges I was showing you, there was an example where there was a snow plow that went across the bridge and hit the end of the bridge and collapsed the bridge. There goes another historic bridge. So, and with a lot of these historic bridges being considered fracture critical, it's also leading the push to replace them.
I was thinking more like some of the modern two-girder bridges and welded steel girder bridges.
That's true.
Turn out, all of a sudden, they're gonna save all this money, and they've been plowing extra money into inspection because of, found out using cold weather with fatigue cracking.
Absolutely.
Retrofit after retrofit, that's all.
Absolutely. No matter what, there are always trade-offs. So.
Thank you very much. That was really great. Remember, we got a walking tour in June 5th at Chatham. Probably your last chance to do it with us. There's sign-up sheets there. Make sure and take a sheet with our speakers, and if you're leaving for 5 months, when you come back to find us, we'll be at Holy Redeemer across the way starting in September.
As a group, are we doing anything to save the civic arena?
To what?
To save the civic arena instead of demolish, I mean, they're planning on demolishing it.
The honest answer is that this group started to do talks and walking tours, and we've never really gotten into getting into historical areas. Sort of left that to the Young Preservationists and History and Landmarks, so we've been affiliated with it. So the group, actually the group doesn't really have a mechanism where we have meetings where we've done that. I mean, you could.
We have a petition, and there's no petition going around.
We do not have that. There are petitions around, but we do not have one. So the talks are there, walking tours there. Please, I will not be here next month. Please come and hear our neighbors from Bloomfield talk about the history of Bloomfield and talk about a book that they have written. Vicki?
Don't forget our Squirrel Hill cleanup, April 25th, Sunday morning, right across the street from North York.
Thank you.
Volunteer and clean up our community.
Good, there's also a slip in the back about a dinner, a lunch on May 1st.
Mary S. Brown spaghetti dinner.
Okay.
May
So,
1st,
so that's around, so we'll be back here next month. Thank you very much for coming.
Thank you.